Shadev number something. Anybody's guess anymore. Next week, we've got Jessica Ivins. And if you've ever been to one of Jessica's talks, you know that you need to be here. It's going to be great. She's an instructor at the Center. So that's Chattanooga's user experience design school. And I think the only 2-year design school, user experience design school in the world. Is that right, Alex? Do you know? Does anybody know? We're going to claim it. Chattanooga has the only one. Okay, guys? And one of their premier instructors is going to come and give a talk on how you know a design is good. And you're going to want to be here for that. Because we all need to know about that, don't we? All right, so today, though, we've got Srushtika. Right there. Hey, wave. Where are you speaking with us from today?
I'm based out of Berlin right now.
Out of Berlin. Okay. So last time you spoke with us, you were in Bangalore. Was that right?
Yeah.
Oh, okay. Cool. So coming to us from Berlin. What time is it there?
Sorry, what?
What time is it there?
The time is 6:08 p.m.
All right. Coming in the evening. All right. Well, Srushtika is a developer evangelist for DreamstreamHub. She's been a longtime speaker for Mozilla, and that's how we originally got connected with her. And we're really happy and pleased to have her back with us today. So you guys give her a warm round of applause. It's all yours.
Thank you, Brett. Hi, everyone. So I'm just going to share my screen real quick. Before that, can you mute on your side, Brett? I'm having a lot of disturbance.
Say that again.
All right. Can you see my screen?
Sure can.
Sorry, I couldn't get that.
Yeah, we can see it. Looking
okay,
good.
Great. So before I start, I cannot see any of you. So if there's anything happening, you'll need to stop me and speak with me if there's anything wrong. Am I good to start? Brett, can you mute from your side? There's some kind of a disturbance. Okay, so sharing my screen again. Okay, so good afternoon, guys. And I know it's lunchtime for you. So today we'll be speaking about understanding the real-time ecosystem on the web. Now, Brett already introduced me. I'm Srushtika Neelakantam, and I'm a developer evangelist for DeepstreamHub. I've also been a long-time contributor at Mozilla, and as he said, that's how I got in touch with Chadevs and gave a talk earlier in May this year about virtual reality. So right now on your screen, you see a lot of applications. I'm sure most of you have worked and used a lot of these applications. Now, all these applications are basically applications that work in real time. But when I say real time, what does it mean anyway? So basically, one way to think about it is that you get a result on your app, on your phone, or wherever you're using the application from. You get the result instantly as soon as the data is being created, wherever it is being created from in the whole world. So that's basically like the bottom line of real-time applications. But then, from what we know of the internet right now, how does this whole real-time system work at all? For instance, we saw the Uber application where the driver's location was updating in real time as the driver was moving in real life in his its car. And we wouldn't even, were we like refreshing the app again and again? We weren't doing that, but still we could see the car moving. So what happens beneath the hood, and how does this whole setup work is what we're going to see in this particular talk. This is going to be a very basic level talk, which will basically cover the basic concepts that go in the real time world. So let's get to it right now. So whenever we talk about real time world, we need to really understand these main paradigms. What we know already is something called the pull based paradigm, which is the traditional way the internet has worked for most of the time. You have a client, you have a server, and you send the request to the server, ask the server for some data or some kind of a service, and it returns it back to you as a response. That's what happens. Also, we have something called data providers, which are like these data sources which sit somewhere else and which are responsible for providing any kind of data that the client requires to the server. And the server plays like the middleman who routes this data to the correct client. That's what happens. But there's this another paradigm that not a lot of people know about, which is push based. What happens in push based is we're not basically, so what we did in pull based was we pulled the data from the server. We asked the server for certain data. So we essentially, it's the client who initiated the whole request every time it needed any data. Whereas in push based, you tell the server once that you're interested in certain kind of data, and the server will start sending you updates as soon as any new data is available. So it's not always like one request and one response back. You just tell the server you're interested, and that's it. For instance, let us consider an example of me being a client and I require some weather data for Berlin. So I would say, hey, server, I'm interested to know what's the temperature, the changing temperature of Berlin in real time as it changes. So the server will be like, hey, you know what? It's 9 degrees Celsius now. And probably after an hour, the temperature dropped or something. And the server will be like, hey, you know what? The temperature right now is 7 degrees Celsius. You might want to know because you were interested. I didn't ask the server this question again. So that's basically push based. I think you get the idea. Now, when we now, according to what we know about HTTP and the way the internet has worked traditionally all these years, push-based paradigm doesn't really make sense, right? I mean, how does it even work? If from what we know of HTTP, it's one request and one response back. What's this push-based at all? So let's actually talk about a couple of communication protocols, mainly highlighting the differences between what happens in HTTP and elsewhere. Now, there are a lot of protocols you can use for communication on the internet, but here we'll mainly speak about only two of them and why they're different when we talk about the real-time ecosystem. So first is, of course, HTTP. Now, it's almost 2018, and I understand that you're not here for a talk which makes you understand how HTTP works. Pretty much all of us know it already. But, just to preserve the consistency, I'm just going to run over it. There is a client, a server, you send a request, and it gives a response back. It's basically the direct implementation of the pull-based paradigm that we saw earlier, right? Now, in HTTP, if we want to implement something like the weather example that I said, where I repeatedly want some kind of a data, some kind of a similar data from the same server, we could do two different things with HTTP. One thing, of course, is Ajax pull, where according to the sensitivity, the time sensitivity of the data that is involved in your use case, I will set up a time interval, and at each time, after each time interval, my client will send a new request to the server asking the same data again and again. So it'll be like, hey server, can you tell me the weather data for Berlin? Again, after an hour, hey server, can you tell me the weather data for Berlin? Etc. So this, although it makes sense, probably say for the weather data, because it doesn't really change at blazing speeds. Probably it changes in every hour or half an hour or maybe 2 hours or more. So Ajax polling would still make sense. Something else that we can still use is Ajax long polling. What happens here is I send a request to the server asking it for some data, and it'll respond back only if it has some data. Otherwise, I implement the whole, the protocol has this keep alive flag, using which you can actually keep the connection alive for a certain time, expecting or hoping that the server gives you back some data. So when we saw the Ajax polling, it's not necessary that every time the response is being sent back, it'll give me some new data. It can just tell me, say, I send these three requests in a span of half an hour. There are chances that the server will send back the exact 9 degrees Celsius as the data every time. There are chances that there's no new data generated at all. So in case of long polling, only if there is some new data that the server would like to respond with, it will give me a response back. So we give it a particular time, hoping that there's some new data that becomes available in a later point of time. But then obviously the amount for which the connection stays open is limited, and it eventually returns a response, be it with the data or just without any data. And as soon as it returns some response, we would start the whole request and response cycle again with the persistent connections. And then we have something called HTTP version 2, with which, of course, you can do persistent connections, but you can also batch the requests and responses. What I mean by this is that you can group a couple of requests and send them all together to the server, to which the server will respond with. Obviously, each request will have a separate response, but you can again group these responses and send it in a single go back to the client. But again, if we think of our use case, our example that we thought about, like the weather example, would it make sense if the client said, hey, server, can you tell me the temperature of Berlin? And these are three different requests, and all of these are sent together to the server. And the server would probably respond all three times with, no, I don't have any new data. And then all three responses will be sent back to the client. I mean, HTTP version 2 makes a lot of sense when you have a particular use case, but in terms of real-time sense, we don't really find it that much useful. So what's really wrong or right with these different kinds of way in which the HTTP is implemented? First things first, you cannot have the server send back any data to you if it wants to initiate something. So only if a client asks the server something, it just has the authority or the power to respond back to this request. If the server knows that, okay, this client was asking for some data, now I have new data, but how would I send it? Because the connection has already ended. That's one thing about it. Even with polling, when you're repeatedly asking some data, there is a lot of overhead involved in each of these requests, as you know already. I mean, there is the connection setup, the authentication phase, the validation phase, and all that involved. And doing this again and again at short intervals will totally make the whole system very slow because of the overhead involved. So what do we do about it? Of course, we have this protocol called WebSockets. Now with WebSockets, what happens is initially a client and a server do the initial HTTP handshake. That is, they connect the usual way they would do in case they were using HTTP protocol. But the client would specify to the server that, you know what, I'm interested in us speaking in the WebSockets language. So let's do this. And if the connection is successful and the server, this is something to make note of. If the server, only if the server knows this language, that means it supports WebSockets as well, only then it will allow the whole connection to be upgraded to WebSockets. And the rest of the communication happens in WebSockets protocol. Now, what's better in WebSockets compared to HTTP is obviously it is a full duplex persistent connection. What I mean by this is the client and the server can now speak with each other simultaneously, and the connection is kept open for the whole time that the application is running. So, for instance, like in this case, I would say, "Hey server, I would like to have the weather updates for Berlin," and the server will be like, "Okay, here's your data. It is 9 degrees Celsius now." And after an hour, the server gets some data from a data provider, and it knows that it is 7 degrees Celsius. That means it is changed from what it earlier gave to the client. So it will be like, "Hey, you know what? This data just changed, and I know you were interested in this, so I'm giving this to you again without you asking for it again and again." And it can do this time because the connection is still open. And whenever you no longer need it, or the server no longer is providing that data for some reason, either of the parties call it quits and the connection is closed. So essentially, if you look at the header information, you would see that in the upgrade flag, you will specify something like WebSocket. And this is a way that the server will know that you're interested in carrying forward the rest of the communication in WebSockets. And as I said, if everything is good, that means the, the server you're talking to supports WebSockets. It knows the language that you want to speak it with. It just gives a response back telling that it is switching the protocols now and you can continue communication with WebSockets. And since the WebSockets initially start off as a HTTP connection, WebSockets support all the features that you would expect from a usual HTTP protocol. Because after all, it started off as a HTTP connection initially, right? So that's how basically our, uh, the applications in real-time system would work. But is WebSockets the only protocol that you would use when you think of real-time applications? The answer is no, because there are a lot of other protocols like MQTT, CoAP, and a lot of other things that you might think of. But you really have to think about the use case that you're implementing, and every protocol has its own pros and cons. For instance, MQTT is a great lightweight protocol which functions very similar to WebSocket, and it is very useful if you have these IoT sensors which are continuously sending some, like streaming some data that they are monitoring back to the client. So for these continuous push uh, pushing of data, you would need something similar to WebSockets. But WebSockets are very complex and come with a lot of overhead to be applied to something like low power devices that these IoT sensors are. So MQTT is a very lightweight protocol and hence is useful in that kind of a case. But WebSockets is usually touted to be like this flag bearer of this whole real-time world, and hence we extensively talk about WebSockets whenever we talk about the real-time scenarios, applications, and things like that. Let's now look at some of the core concepts that come to mind when you talk about the real-time world. So any application that works in real time would definitely be implementing all or a subset of these features. So let's understand what all these features mean and how you can further see how you can implement something like a real-time application on your own. So starting off with PubSub. Now PubSub is a shorthand for publish and subscribe. What happens in publish and subscribe is, let me give you an analogy. So for instance, we all read newspapers, right? I mean, I don't, but I'm sure you all do. So what would you do? Would you rather go to a shop which is near your house every morning and buy a newspaper in order to read it? Or would you just pay for the subscription and let the newspaper boy have it delivered to your doorstep every morning so you can consume the data? That's exactly, obviously you would choose the latter, right? So that's exactly what happens in publish subscribe. There are these publishers who are continuously streaming the data that they have, and there are certain subscribers who tell these publishers that they're interested in getting a subset of the data that they're publishing, and they will be automatically given this data as soon as this becomes available. So as soon as a new newspaper comes up every day, we are given that newspaper, right? So as soon as any new data is being created and is being published by the publisher, it will be automatically given to the subscriber, which makes sense. But then obviously, even though on a high level we talk that the publisher is the one who's giving this data to all the subscribers and the clients, there's obviously a server involved in all these cases, which is doing the routing business, has a business logic of routing the right information to the right subscriber or the client. Now, publish subscribe is basically a message pattern, and it would mainly work in two different ways. It can be either a topic based or a content based. In topic based, publishers specify certain channels in which they publish all the data. For instance, there is a data provider who's sending out weather updates, right? Now, if it was working on topic based, then it would say, you know what, I'm going to publish all the data uh, based on country. So I would publish the weather data for USA, for Germany, for India, and etc. Now the subscribers are only allowed to subscribe to any of these existing channels. So they don't really have a way to, subscribe to a subset of these channels. They have to anyways deal with the redundant data, even though they don't require it. That's topic based. So for instance, if I would like only the updates about Berlin and not the whole of Germany, I can't really do that because that's the only thing available on the menu. I can't choose anything other than that. So, yeah, so that's topic based. And then in content based, publishers basically stream all of the data that they have, and subscribers are allowed to choose the subset, like the exact fine grained subset of the data that they require, eliminating the redundant data that flows between the publishers and the subscribers through the server. Now, of course, in this case, as you would imagine, the server would have a lot of overhead in managing all this data that is being published by the publishers, and then routing the correct subset of data to the subscriber who wants it. But then there are always workarounds with it, with different kinds of real-time platform as a service and infrastructure as a service companies or products that provide you with. We'll see those later on in the talk. Next, we have something called data sync. Now, I'm sure whenever I say data sync, the first thing that comes to your mind is probably the Google's collaboration tools like the Google Doc and presentation tools that two people are, or two or more people are simultaneously working on, and everything is synced. Well, on the high level, that's actually true, but data sync actually means a lot more than that. As PubNub on their website describes data sync, it is basically the state of the application remains synchronized across all the clients who are using your application at one particular point of time. So, if you think about this real-time applications and all these real-time scenarios, the data updates in such blazing speeds that you can't really afford to have. For instance, you have a document and hundreds of people are working on it. You can't afford to have someone update a document that has already been deleted by someone, because there's very little time difference, and you have to make sure that the state of the document remains exactly the same across all the clients who are using it. I think you get the idea of it, right? And next, we have something called RPCs. Now, RPCs are remote procedure calls. These are mainly like the request and response pair that happens in HTTP. But what's different with RPCs is that if you request a remote procedure, like if a client requests a remote procedure to a server, you do not have to worry about the load balancing part that you would rather have to if you were dealing with HTTP. So that logic is intrinsically applied because we have providers who are providing that RPCs, and it is possible to have more than one provider providing the same RPC. In which case, the server would choose one provider randomly out of all those who are providing the particular RPC that the client is requested for. Now, the first thing is the provider is being chosen randomly. Even after choosing the provider randomly, say we chose P2. Now, P2 already is dealing with 3 other requests and it's really busy. So there is a way in which P2 can reject the request to provide the RPC and tell the server, you know what, I'm busy right now. Why don't you go ask another provider who's providing this RPC? And the server would then randomly choose one provider among the rest of the providers that are available. So load balancing is basically intrinsically solved, and you don't have to implement any new business logic in order to have that in your application, right? And then we have something called presence. Now, presence is a very interesting feature. Now, how do you think all these social media applications, manage the login and log out of the users of their applications? So you know that if you're using Facebook and your friend logs in, you would see a green symbol beside the person's icon, and then if the user logs out, it would turn gray automatically. You're again not refreshing or anything. And how does this happen? So this particular scenario of tracking user logins and logouts is called presence in the real-time world. And a lot of like whichever most of the products which offer you platform as a service or infrastructure as a service for building real-time applications have the feature called presence as well. Even when you think about gaming applications, you're having like multiplayer games and things like that. Presence is the one which lets you, which basically, so how presence works is, as soon as a user logs in or logs out, there is an event which is published. And all the other users which are part of the same application are subscribed to this particular event. So whenever this is published, you get notified. And by getting notified, we can basically apply any logic into that notification. And what we do is, according to the use case that we're implementing. In terms of Facebook, we just turn the green icon to gray and do a lot of other things. That's another story to tell, but you get the point, right? And next, we have something called real-time search. Now, if you remember, Google provides, real-time search for news articles. For instance, there is some, worldwide famous news that has happened. So everyone in the world is right now Googling to know more about that news. But it has just happened. So the news channels and all these reporters are continuously publishing these articles. So what happens is Google has this real-time database where the results are continuously updating, and then some client at some corner of the world asks the server, you know what, I would like to search this particular term out of your whole real-time database. So server wouldn't really do a lot here. It would just ask uh, for the particular data. But there is always some logic in the middle between the server and the real-time database. A lot of products call this as the search provider, or you can call it whichever. So this particular logic is the one which takes out the data that is matching your search term and then giving it back to you. But if there is any change in the results, according to the query that it performed, it would again send back the results continuously to the client. So if you actually see the Google page while with real-time search, the news articles are updating, and sometimes they're updating in such speed that it becomes hard to actually look at them or probably click at them. So they also provide an option to pause the loading of new articles so that you can actually sit in peace and look at the articles which are already available. That's just one use case for real-time search. You can have a lot of other things that you can use with real-time search. It's basically cool, isn't it? I mean, the database is updating in real time, and as it is updating, and if there's something matching to your query, you're continuously being sent all those things as well. That's what real time is all about, isn't it? Now, by looking at all this, we somehow have this feeling that real time is very hard. I mean, implementing real time applications might be very hard. There are a lot of these, underlying protocols that you need to take care of, and you need to ensure speed, because real time is always about the speed with which things work. Of course, one thing to note here is that it's not always something that happens instantly. So it's not always the case that the data is being created and at that right moment, everyone who's interested, like who subscribed to that data, is being given the updates. Sometimes there may be cases like Twitter updates where a person has tweeted and after 5 minutes is when you get the notification that a person has tweeted. It doesn't really matter because it's very much um, use case dependent. But the thing we need to note here is that there is some particular um threshold value to the time that it can take at max, before which the data should be returned back to the client who's requesting it. So real time, again, coming back to this, we have this intrinsic feeling that maybe applying real time or implementing real time applications might be pretty hard. Well, it seems to be pretty hard if you think about applying everything from scratch. I mean, it's 2018 almost, as I said, and we don't really, I mean, no one really does everything from scratch. There are services for everything, and you might as well use an already set up service and plug it into your application, or start building a new application with in conjunction with all the other APIs and SDKs that are available in the market. So if you see that way, there are a lot of things that are available out there, like DeepstreamIO, Pusher, Socket.io, Meteor, Firebase, PubNub, and I'm sure there are a lot of other things that are not present on this slide. And the way they work internally and the APIs are obviously different, and they provide different trade-offs in terms of speed and things like that, and they provide different features, of course. A couple of them are open source implementations, a couple of them require you to pay for their use, and you really have to think about your use case before starting off with using any of these solutions. So a lot of these are either platform as a service or infrastructure as a service, or even standalone servers that just run by themselves and let you host your applications in real time. So also all of these definitely provide all the core concepts that we spoke about earlier. So in order to make sense out of what I've been talking about until now, let's actually look at a few examples. Let's look at three examples, starting with the most basic example that you can think of, and ending up with something like a multiplayer game that you will interact with me from Tennessee and me being in Berlin, obviously. So, starting off with the most basic one, as I said, let me show you this example where I have a basic HTML file. And of course, I'm using Deepstream for this example. Uh, and I would publish certain events. So I'm mimicking the behavior of a data provider right here in the publish.js file. So this is a Node.js file, and I'm requiring the Deepstream JavaScript client, and I'm connecting to Deepstream. Obviously, beneath the hood, it's working on WebSockets protocol, secure WebSockets, and then I log in. I'll have the client log in, and then I'm just emitting this particular event with the name my event, and I'm sending back the data, the current date plus time, which is returned by date not date dot now function, and I'm emitting this every 1,000 seconds. Of course, you would never do this kind of a thing in real life. You would actually have a provider who's by itself, providing you all the data as it is being created. You're not even creating any new data here. I'm just sending like the new date and time every 1 second. Whereas in my client, what I'm doing is I subscribe to the event, the same event that we are publishing here, which is my event. And then a callback would be fired every time there's any change in this event. Basically, whenever this event is published, this callback will be fired. And within the callback, I'm just changing the H1 element and setting the data to the data that is being sent, which is date.now. So let's actually quickly run this and check if it works and how fast it does. So I've opened it here, and I'll quickly run the server on Node. Okay. Okay, here we are, and I would say node publish.js. Now, before I execute this, we have the client open already, and we know that the client has subscribed to this data. Now, imagine that this publish.js is some data provider who is providing some data from elsewhere, from some other corner of the world. And as soon as I start publishing, we see that the data in the browser starts updating, like instantly. As it is being published, it is being updated. Now, you might think that it is so fast because I have both the files on locally on my machine, but I'm not sure if you observed that both the publisher and the client are actually speaking via Deepstream and not speaking locally with each other. So there's no way that we can say that it is as fast because they're on the same system. Now, this is such a simple, application where we have less than 10 lines of code, and our application is already working in real time. Now, I have still not updated or refreshed my client, and if my data provider stopped publishing, and now it has again new data, and it starts publishing again. Let's see if that updates again, and it does. So if you see, the data is started changing again. So that's what I mean by real-time updating data using WebSockets and how fast it is. So let's actually look at another example. This time, let's look at an example that describes the presence feature that I said, which basically tells you the login and log out functionality in all the social media applications and gamings and stuff like that. So I have an application here which was built by my friend here at Deepstream, and basically what it does is you are allowed to choose one color. So each browser would act as a new client, right? So I'm going to set up different clients, and say I have 3 clients, right? Now I'm going to open this application in all the 3. So what happens here is when I pick a color in one of these windows, then it means that the client has basically come online, and we should essentially see that change in all the other users window as well. So we have 3 users. Let me pick a color in this window, and um, it turned the color that I chose. So it's working in both these windows as well without me having to refresh. Now, let me actually make this user go online. I would say choose this color. Okay. And then when I chose this, that means this person has come online as well. And this person knows who else is online. Now, in this case, we're just doing it with colors, but essentially you will have user IDs or the usernames with which you identify different users in your application, right? Now, this user is the one who comes online, and then the whole thing updates in real time. Now, what happens if a user leaves? So if I close this browser, the user leaves in all the on all the other client side as well. So basically, it's publish, subscribe plus data sync both together in real time. That's what is happening here. Cool. So I think you've got a very basic idea of what, like, how real-time systems function and what really goes behind the hood. But in order to really, understand what really amazing things that we can build with real-time applications, let us see this final example that I built a couple of weeks back. This is built in VR, and I'm not gonna go through the specifics of how it was built in VR. All I can say is that I used the A-frame framework to conveniently build the virtual reality application using just HTML. And of course, the real-time functionality is what I've implemented using Deepstream, which again works on WebSockets. So this basically, if you observe this URL, it's basically an app URL that you get when you create an account on DeepstreamHub's platform, and that's what it is, in case I forgot to mention earlier. And in login method, we are basically not authenticating the user at all, because this is just for a example that I'm showing to you, and I'm not doing any profile management and things like that. So I'm going to show this application to you, and I want you all to open up your phones right now and hit this particular URL, which is tiny.cc/VR charted. I'm not sure if you guys are listening to me, but I'm assuming you are, and I'll give it a little time. So this is basically a VR application, and you will see something change as you start logging in. You can all do that on your phones. So here we have the first person, and here we have more and more people. So what's happening is, as you are logging into the application, I have used presence in the code, and I'm just firing a callback just to track user logins and logouts. And as soon as a person is logging in, I'm just making an avatar for the person, and then tracking the person's phone's position, and then implementing the same thing with the avatar as well. So we have presence, we have publish, subscribe, we have data sync. Now data sync is basically your phone's position is being taken. Okay, this part is tricky because how the position of your phone is tracked is with the camera component that is part of A-frame, that's completely VR part. But what's real time is that this changing position is continuously being updated in a real-time database, and which in turn is being implemented in the avatar, and hence the avatar is able to move in real time. So I'm not sure if you guys can identify which of these you are, because all the avatars, I've just made them to look the same. And if I just turn around, probably I can just move around in this application. And also you will observe that your movement is restricted to just the x-axis, which is intentionally done just to avoid scattering of the avatars in the whole 360 degrees here. So this is basically how you would build any multiplayer application as well that works in real time. There are a lot of use cases for real time, like chat applications, IoT, and text collaboration tools that you can conveniently build using any of the solutions or products available out there in the market. And there are open source solutions as well. So obviously there is a community out there which is always working, and you can contribute back, and you can ask the community if you get stuck somewhere, and of course they'll be happy to help you back, like in any other open source project. So with that, I think that's all I wanted to say. And basically, with real time, it feels like, there is an event emitted at one corner of the world, and instantly, everyone who's interested in that event get instant notifications and knows about something has happened. That's real time for you. It's all about speed. Thank you very much. You can tweet me your questions or email me your questions. And of course, you can also ask me your questions if you have any right now. I'm going to switch back to the Zoom.
There we go. All right. Got time for a few questions. Anybody? Right here? That was a fake. That was a fake out. Just kidding. Anybody? Going once, twice? Thank you, Srushtika. Thanks so much. That was great. Round of applause. Thank you. I'll catch up with you later.
Yeah.
Thanks, Chadev. Closing words?
Sorry?
Closing words?
No, I'm just
All
going
right.
to leave.
Cool. We're killing your video. I'll talk to you after. Come back next week, Chadev. We'll see.